Machining, as we know, is the art of removing unwanted metal from a workpiece with the help of a single point or a multi-point cutting tool. In our case, in this video, let us take the example of a single point cutting tool. And on the left hand side, we can see a metallic workpiece. Now, as soon as the tool comes in contact with the workpiece and we start applying force with the help of the tool into the workpiece, what happens? The tool starts removing some unwanted metal from the workpiece in form of chips. Now, what are these tips? Let us try to understand with the help of this photograph. This is a drilling process and we can see that some spiral shaped objects are coming out from the holes. These are nothing but are the unwanted objects which we call as chips in the machining. The unwanted metal pieces which we don't want, we try to remove this now with the help of visualizing this cutting process. We have shown a three-dimensional view of the setup where a single point cutting tool is removing some amount of metal pieces from the workpiece in the form of chips. The direction of the cutting tool and the chip flow are shown with the help of blue colored arrows. Now see, this chip formation takes place due to shear force. To understand the entire game of chip formation, we have to first understand the concept of shear force very clearly. So let us assume we have a rectangular bar where we are applying forces at both ends. If we are trying to elongate this bar, so such kind of forces, as we know, are called tensile forces. Now in the same bar, if we reverse the direction of these forces, what will happen? The forces will try to compress the metallic bar. This kind of forces are also known as compressive forces. Now in the third case, let us assume we have a metallic cube and a force is applied to the top end going from the right to the left hand side and another force moving from the left to the right. The result of these two forces on the workpiece will be that the workpiece will be sheared away. Let me give you a very easy example of shear force. Let us assume we have a scissor and we are trying to cut a piece of paper with the help of the scissor. So when we try to cut the paper, a downward force is applied from one of the scissor blades as seen in this diagram, while an upward force is applied by the second blade. The result of cumulative effect of these forces is that on the paper is that the paper in between these two blades will be sheared away. So this is what shear force is all about. So let us now try to understand the chip removal process more closely. As we can see in this diagram, it is a 2D view of the cutting process where a single point cutting tool is removing some metal in the form of chips. The face of the tool that is rubbing the chip is called the rake face, and the space which lies just near the machine surface is also known as the flanks or flank face. By the way, the machine surface is nothing but it is the newly generated surface of the workpiece. So now, when the tip of the tool starts applying pressure in the workpiece, what happens is that the elastic deformation starts taking place. So as we go on applying more pressure, it exceeds the yield strength of this material and then plastic deformation starts to take place. The plastic deformation will first begin from the region. This is also called the primary deformation zone, and this plane, it is also known as the shear plane because shear forces are acting on this plane. So now the angle made by this shear plane with the machine surface is also known as the shear angle and is denoted by phi. We didn't usually denote it by phi. Now there is another zone where the second stage of deformation takes place. This is also called the secondary deformation zone, as we see in this picture. It happens just when the chips rub vigorously with the rake face of the tool while flowing out. A tremendous amount of friction is generated actually here. So now there is an important parameter called the rake angle. What is the rectangle? It is nothing but the angle made by the rake face of the tool with the perpendicular drawn at the tool tip. This parameter is very important because it directly influences the shear plane angle and the airplane area. For example, if we have a very large rake angle, it will happen resulting in a smaller shear plane area. So small shear plane area is desirable Because of now, the forces, if this airplane area is small, the forces required to form the chip will decrease. As a result, less amount of temperature will be generated. So we can see that there is a direct influence of the acrylic phase on the cutting tool. Also, the power required will also be less in this case. So lastly, we have the clearance angle, which prevents the flank face of the tool from rubbing the machine surface. If the flank face, there is no clearance, what will happen? The flank face of the tool will rub against the machine surface and some amount of friction will take place, which will deteriorate the life of the tool as well as it will deteriorate the surface finish of the machine surface. So we don't need all these things. Hence, we are giving a small amount of clearance now. Care has to be taken that the clearance angle should not be high or too less. There has to be optimum limit. So this was all about the clip formation. Now that we have reached the end part of this lecture, let us summarize what we have learned in this lecture. First is, chips are unwanted metallic pieces that comes out during machining. Then we saw that the chip formation takes place mainly due to shear force imparted by the tool on the workpiece. Third is that the clip formation starts from the primary deformation zone in the shear plane, followed by another deformation in the tool chip contact surface where tremendous amount of friction is generated. This is also called as the secondary deformation zone. And finally, we saw that rake angle, a very important parameter, determines the shear plane area, which in turn determines the amount of force and energy required for cutting. The selection of proper cutting tool geometry is of the utmost importance when doing an effective cutting. In this video, we will provide a clear explanation of the cutting process and tool geometry. To remove a metal chip from a workpiece, you have to cut at least two surfaces. Cutting along just one surface will not guarantee chip removal. For this purpose, cutting tools are provided with two cutting edges. Cutting tools. A main cutting edge and an auxiliary cutting edge. The main cutting edge cuts the main portion of the chip, while the auxiliary cutting edge cuts the second surface and removes the material. You can see the smooth corner between these cutting edges. This corner is known as the nose of the tool. The radius of the nose greatly affects the surface finish of the operation and the strength of the tool. Rake angle. Material removal by the main cutting edge is easier when the material's flowing surface is at an angle. This angle is known as the rake angle of the tool, more specifically as the back rake angle. Greatly affects the chip thickness and the force of the cutting to avoid the rubbing of the cutting tool, while the workpiece, a relief angle is provided as shown. Relief angle. Similarly, rake and relief angles are also given to the auxiliary cutting edge. A cross-sectional shape is shown here. Now let's have a look at the tool's initial position. You can see that the cutting edges from angles as shown, they are called end and side cutting edge angles. These 7 parameters together completely define the geometry of a tool. We hope you have now a conceptual overview of cutting tool geometry. Now, we will discuss about the chips formation and chip formation types. Firstly, we will discuss about the discontinuous chips and how they will form. We will have a workpiece and a single point cutting tool. This single point cutting tool will travel on the workpiece and remove the material, and hence discontinuous chips are formed for brittle material. If we use single point cutting tool on a brittle workpiece, then what will happen is that the single point cutting tool will travel and material will be removed, and such types of chips are formed in fragments, and these are called as discontinuous chips because they will be formed in fragments. Now we will discuss about continuous chips where we have a workpiece and a single point cutting tool. When the single point cutting tool will travel on the workpiece, it will remove material and continuous chips will form. In the case of if the workpiece is ductile in nature, such type of chips will be formed which are known as continuous chips and will be formed. Last but not the least we have is the build-up edges where a workpiece and a single point cutting tool is being observed, and single point cutting tool will travel on the workpiece and remove material. But due to high friction between the tool and the workpiece, the built-up edges will be formed on the workpiece. These built-up edges are chips welded to the tool which will affect the tool quality. So these are called built-up edges because they reduce the efficiency of the tool cutting speed and cutting efficiency, hence the name given as built-up edges. And so these are the types of chips formations. Thank you.